Hello, so today we're going to be looking at this reaction right here. And when the concentration of diatomic X doubled the rate, tripling the concentration of Y tripled the rate, and doubling the concentration of X did not change the rate at all. So why don't we try to write a rate law? So the rate is equal to K times the concentration of X squared Y and Z. So doubling X led to a doubling of the rate, so there would be a 1 there. Tripling the concentration of Y tripled the rate, so that's also 1. And doubling the concentration of Z did not lead to a change in rate. So that means that there's a 0. Z isn't in the rate law. So our rate law is right here. So K times the concentration of diatomic X times the concentration of Y. But why isn't Z part of this rate law? Well, it just means that Z isn't a part of the rate determining step. So why don't we try to write a mechanism for this? So given our rate law here, that means that the slow step would involve the diatomic X colliding with one molecule of Y. So X would collide with Y to make XY and an X. And this would be our slow rate determining step. And that matches what we see here. When the rate law, it also matches one of the products, but Z is also involved. So we would have X and react that with X from this step. It would be an intermediate. We take that X, we react it with Z, and we would get the other products, XZ, as we see here. And this would be the fast step, so it wouldn't play a role in the rate, but it does give us the product that we need. And so here is a perfectly plausible mechanism, which agrees with the rate law that we see here. And Z is not part of the rate law because it is not part of the rate determining step.